It's time for the last lesson in this unit. It's the last thing that we will learn before exam 3. And this is the lesson on antiderivatives, which for some reason is in the end of chapter 4. I asked you to do certain questions from our textbook. I will work through some of those questions, leaving others as exercises for you. I figure if I show you the basic idea, you can take it from there. So let's dive in if we can. I asked you to do question 471 that says that f of x is e to the x minus 3x squared plus sine x. You were asked to find an antiderivative. Antiderivatives are generally written with capital letters. So what's a thing whose derivative is e to the x? Well, e to the x's derivative is e to the x. That makes sense. What's something whose derivative is 3x squared? Well, that something is probably x cubed. Remember, the 3 would come down in front. You got that. What's the thing whose derivative is sine x? Well, the derivative of cosine x is negative sine x. So the derivative of negative cosine x is positive sine x, and as with all antiderivatives, there's some constant at the end because vertical shift does not affect what the slopes are. So I am fairly confident that if you knew how that worked, then working through 473 and checking in the back of the book goes okay for you. 475 asks you to find the antiderivative of this. And this gives us a chance to talk about the power rule as it reverses. The antiderivative, something whose derivative is x. Well, if we had an x squared, right, the 2 would come down in front, and then this would decrease to 1, but then there'd be a 2 in front. So we need something that neutralizes the 2 that's going to come in front. That neutralizes the 2 that's going to come in front. And this is the sort of thing that we can expect to see when we find an antiderivative of a polynomial. The power goes up instead of down. Power goes up instead of down, and we divide by the thing we put up there. This seems to be the way this goes. Similarly, how do you get something whose derivative is x squared? Well, that antiderivative would have an x cubed in it. 3 comes down in front, power decreases to 2, but we don't want a 3 here, we want a 12 here. So what do we have to put here so that when the 3 comes down, the product is 12? That seems like it's reasonable. And as with all antiderivatives, there's a constant at the end because vertical shift doesn't affect slope at all. If I may, 489, I asked you to find the antiderivative of this. And you're already thinking, wait a minute, we've already done part of this over here. So what's happening over here? Well, you and I both remember that the antiderivative of e to the blah is e to the blah, right? Like we remember that part. But then when we check ourselves, when we take the derivative of this, the derivative of this is e to the negative 4x times negative 4. And we don't want a times negative 4 here. We want a 1/2 here. So we need something that when we write times negative 4, whatever's here multiplies with that and leaves us a 1/2. So what is that? There it is. If there were a 4 here, and I suppose we could, if there was a negative 4 here, this would multiply to that. And as with all antiderivatives, there's a plus c. Okay. I also asked you to do some questions involving indefinite integrals. And for now, all you need to know is that this symbol, the indefinite integral symbol, that symbol means that we are writing down the most general antiderivative we can write. We are writing the most general antiderivative that we can write. So this symbol means find an antiderivative. And we can do that. The antiderivative e to the x is e to the x. Antiderivative e to the negative x is probably e to the negative x, but wait a minute, when we check ourselves, the derivative of e to the negative x is e to the negative x times -1, so we need something here that's going to multiply by that -1 and leave us with a plus sign, and that appears to do the job. And as with all antiderivatives, there's a plus c. So this is the indefinite integral of e to the x plus e to the negative x dx. Okay. I also asked us to do question 500, which said, suppose that f prime of x is square root of x plus x squared, and suppose that f of 0 is 2, and as soon as you see one of these, this is what we call an initial value problem, because we have an antiderivative, but we can find the c because we have this information sitting right here. So we think to ourselves, what's an antiderivative here? Well, the antiderivative of x to the 1/2 is going to have x to the 3/2, right? Because then the power decreases by 1. But then when we check ourselves, this 3/2 comes down in front. We don't want a 3/2. We want a 1 in front. So we need something that undoes that 3/2. And then similarly, the power goes up by 1. We want, when the 3 comes down, we want something that neutralizes it. This neutralizes it. And as with all antiderivatives, there's a plus c. So now we use this piece of information. We know that if the y value is 2, the x value is 0. And that tells us that c is 2. And so the function must be this antiderivative we thought about plus 2. Okay, so then you can work out the other questions, check them in the back of the book, check with me by email if necessary. This is the last topic that could appear on exam 3. Something like this makes an excellent short answer. Something like this makes an excellent short answer question. So I would encourage you to be familiar with this sort of thing. All right, excellent.